Good afternoon, good night, wherever you are. Thank you for attending our panel. I would like to start by thanking the organizers of the PMRC 2021 for accepting our proposal on the theme of towards global 6G connectivity. The panel is about connecting remote and rural area, as well as dealing with connectivity in low-income neighborhood. As you know, with the beginning of every decade, there is a big interest in getting into the design of the next G. Now we have seen over the last 2 years a great interest in trying to define what 6G might be or what 6G should be. Part of the work has been more on trying to push the envelope in order to pursue some of the application displayed in front of you. But of course, another important aspect that is being examined is to remember that roughly half of the world population, a number roughly around 3.8 billion people, are still not benefiting from the internet. And one may argue, based on early 5G deployment, that let's call this connectivity divide between the connected and non-connected or underconnected is kind of expanding. And as such, that's an important problem that we need also to address. Environment or the low expected revenue calculated as average revenue per user, the well-known ARPU in low-income neighborhood. So why did we fail achieving this so-called global access to internet for all, or Gaia? One way to explain that is by looking at the diagram displayed in front of you, illustrating the dependence of the quality of experience versus the cost per user in low density population areas. And you can see from this diagram that the traditional geostationary satellite communication system, which we know are great for TV broadcasting, actually offer limited bandwidth and suffer from high latency as far as internet browsing is concerned. So they cannot deliver the fiber optic type of quality we are aiming for. The same diagram that you see in front of you shows that full deployment of fiber optics or microwave links is not really economically feasible for remote areas and rural areas, which are typically characterized by a low density population. So really what we are aiming to is to go for what we can call the global connectivity holy grail on the top left of the diagram displayed in front of you. And what we want to do is to, in a way, achieve the best of both worlds and target a terrestrial fiber quality, but with a global satellite coverage, fulfilling hopefully this very interesting statement made more than 100 years ago by Nikola Tesla, and that you can read in the slide in front of you. Many solutions are being pursued to achieve the so-called global connectivity, and this without relying on the deployment of costly infrastructure on the ground. In particular, one potential solution is the use of three-dimensional integrated networks that include terrestrial base station, but also they would include airborne base station attached, let's say, to high platform, balloons, or high to platform, as well as, of course, space networks that are relying more and more on these mega constellation. These three-dimensional network can adapt their structure and their resources in order to kind of meet the requirement of the users on the ground. So this is a basic theme of our panel about global connectivity. To discuss this issue, we have six distinguished panelists: Sudhir Dixit from Basic Internet Foundation in Norway, Abhay Kandikar, IIT Kanpur, India, Abhishek Tiwari from the Facebook Connectivity Lab in the US, Albert Risco from the Council from Scientific and Industrial Research in South Africa, Marco Di Ranzo, Centrale Supélec France, and Haris Gakchin from RWTH Aachen University. So we'll start with some opening statement given by each one of the panelists, and then we'll move to the live Q&A debate and question. Thank you for your attention.
Hello, welcome to this panel. Today, we will talk about some of the challenges that are involved in deploying the broadband access technology in the rural areas. In the developing countries, cellular mobile technology has become the primary broadband access mechanism, and there are some issues involved in rolling out the cellular mobile technology in rural areas. The first issue, of course, is that high capex and opex cost, and this capex cost is both in terms of the spectrum cost as well as the cost of the backhaul networks. There are other issues in terms of the backhaul, particularly the access constraints such as the rights of way. Other challenges are in terms of challenges of manageability. We may not have the availability of trained manpower to be deployed in such rural areas. Population also may be sparsely populated, and sometimes it may be remote and difficult to reach regions also. Then there are scarcity of resources. We may not have uninterrupted electric power supply from the grid. And finally, low average revenue per user may not make a business sense for the operators. And this actually requires the new business model. In fact, the telecom operators also spend a significant amount of money in managing the network, in servicing its subscribers, and also acquiring the subscribers. We believe that a decentralized way of managing the networks, and this experiment has been tried in India in the form of village level entrepreneurs, or the VLEs. These VLEs actually manage the local access networks. They actually manage the subscribers. They are responsible for maintenance of the access networks, and they actually may buy the bandwidth from the large telecom service providers, who then become the bulk bandwidth provider. Such a decentralized way, and the community networks and the participation of the community can actually drive down the cost. In terms of the wireless backhaul, again, here we believe that it is important that from the fiber point of presence to the first or the last mile of the access networks, it may be desirable to have the wireless based backhaul, and that is what we call it to be a middle mile. Now, these wireless backhaul networks can come in many different ways. It can be a point-to-point networks. It can be a multi-point-to-point networks. We have experimented that in some of the rural parts of India, this wireless middle mile based upon the TV white space spectrum band as well. Finally, it is also important to see that we deploy the energy efficient solutions. And in order for the alternate energy sources like solar to be feasible, it is important that the power consumption of the base stations and the access points are also reduced. Some of these may actually require even architectural and technological changes as well. Thank you.
Hello, everyone. It is my pleasure to participate in this panel addressing the theme of connecting remote areas and low-income neighborhoods. I would like to thank Professor Mohammed Slim Louini and the conference for inviting me to this important event. My name is Albert Lisko. I'm with the Council for Scientific and Industrial Research, CSIR. CSIR celebrated 75 years just last year. The CSIR's mandate is to do research and technological innovation to foster improvement of the quality of life of people of the Republic. Well, considering this mandate, it shouldn't be a surprise that CSIR has been working in the field of improving telecommunications for rural areas. My colleagues developed Wi-Fi mesh networking technologies, which were deployed in over 200 rural schools with over 100,000 learners. I participated in the next generation of technology, television white spaces. Television white spaces is a type of dynamic spectrum access technologies. We started with research in cognitive radios, participated in the large trials, which connected over 20,000 people to internet. And the CSIR has developed geolocation spectrum database, the heart of TV white space. And this database, together with regulations, became adopted nationally and deployed and is serving South Africa now. You can check for more details in the link below. Now we started to work on cellular technologies going into 5G and 6G. Well, I wanted to make a quick stop and talk about the value and economics of telecom, because at the end of the day, this is the type of equation that defines how quickly things grow. I'll start with the end. The end users, they buy data because of the value provided by the internet, which means in order for them to buy more data, they need relevant and useful services, and such services as OTT, over the top. For a network operator, on the other hand, the viability is defined by ability to make profit. And there are two ways to increase profit: is to increase revenue, which means to sell more data and services, back to the question of importance of usefulness of those services, or to reduce costs. And in terms of the costs, well, there's a number of those costs that can be well, improved upon, both operational and capital expenses. Well, in particular, I would like later to speak about sharing of infrastructure, sharing of spectrum, as key to lowering the costs for rural deployments. I'll skip a few slides, given the time limit, and won't go into the reasons for 3 billion people being in network coverage but not using internet, and all the postponed talking on linking between frequencies, coverage, and costs. Results in US and South Africa. And I think, yeah, in the panel, we'll hopefully also touch on optimizing operational costs through lowering power consumption in the next generation network. So in a summary, I would like to highlight the following technical sides related to availability and affordability of internet. That is access to electrical power, policies to promote generation of more data, regulations to help with sharing infrastructure and spectrum, the importance of aligning physics with business and how it helps to save on the costs. So lowering operational costs through lowering energy consumption by changing the structure of architecture of the network. Lowering research and capex, I think well-known current trends around shared developments and design for easier, more compatible deployments. And hopefully we will get a chance to also discuss the topic of enabling uptake by small businesses, as well as topics of having more satellites in the sky and new technologies such as hubs, high altitude platforms. Well, another side, of course, is relevance and readiness of users, relevance to users and readiness of users. And this includes language barriers, locally useful applications, and the, perhaps very mundane but critical awareness of internet and its value. Well, it's a lot to do, to discuss. And here I would like to bring example of Thomas Edison. His to-do list was 5 pages long, yet he managed to get 45 patents in a year. Well, I think we can follow this wonderful example. Thank you very much, and I look forward to the questions and discussions. Thank you.
Hello, everyone. Thank you very much for inviting me to this panel titled Towards Global 6G Connectivity at PIMRC 2021. So the title of my talk is The Painless Approach, and I will try to describe a little bit in the following slides of what it means. Before I get started, just a couple of words about myself. So I am with CNRS, which is the French National Center for Scientific Research, and Paris-Saclay University in France. So my research group and research laboratory are in Paris downtown, not very far from Paris, downtown. And we specialize primarily in wireless communications systems and networks. So today I'm glad to share with you some projects that is called Painless. It's a project funded by the European Commission that is titled Energy Autonomous Portable Access Points for Infrastructure-Less Networks, which is actually focused on connecting the unconnected, as we will see in the following slides. The project started in October 2018 and is going to end in September 2022. It's a €4 million project where there are multiple partners involved. It is coordinated by University College London in the UK, and there are many partners from Europe who are actually working on the research topics that I will explain to you in the following slides. So, what is the motivation of this project? As I said, it's truly connected the unconnected. And what is the main idea? So the departing point of the Painless project is that the availability and also reliability of the power grid is a bottleneck which cannot be ignored in order to provide the connectivity for future generations of wireless systems. So this can be is a problem from different point of view, from different angles. For example, if we consider developing countries, the booming of mobile networks cannot be accommodated because of the limited power grid infrastructure. For example, if we look at Africa, only 10% of people have access to the electric grid, and the cellular coverage is only 15%. And we cannot basically keep up with this fast-growing market by using conventional electricity hungry base stations. So this is just an example, but you can see in this table, for example, this current situation for off-grid and bad-grid base stations in multiple regions, I mean, of the world. So this is one angle. Another angle is that, for example, in refugees host countries, the development of the broadband internet access is important also for humanitarian actions, and this is extremely important. On a different side, in the developed world, there is also the need of having reliable connectivity in emergency network situations, and also, I mean, when we need to develop rapid connectivity in areas that are affected by any sort of disasters. So also, always in developed countries, there are some regions where, I mean, the broadband penetration is very low. So we need basically to develop techniques that allows us to make sure that we provide the connectivity everywhere we need with high reliability. And therefore, there is not only a spectrum crunch, but it's also a power crunch because of the way that cellular networks have been conceived and developed so far. Therefore, Painless in 2018, the people who are actually working in Painless started conducting research on a new approach that allows us to develop what we call the energy neutral networks. So networks that are self-powered and that they are unplugged from any fixed infrastructure. We call them infrastructure-less. So in this context, having the possibility of grid-independent base stations is extremely important. Therefore, we are exploring some possibilities in order to enable this, for example, self-powered communication networks that have attracted already some interest, and so basically developing and identifying technologies that allows us to develop new base stations that combine together, that are based on combining together renewable energy and conventional techniques. It's very important. So what kind of approach we have taken in order to tackle this issue? So we want to define and also demonstrate this energy neutral concept and an infrastructure-less operation. So the idea is that we want to design a wireless networks that can be self-sustain itself from the power point of view. It can also self-organize itself, and by taking into account that the power grid can be, for example, unreliable. Therefore, we would like to change a little bit the paradigm from the current wireless designs that are based on dynamic wireless signal and interference management, that are based on the assumption that there is a static power supply, into a system where basically there is an interference of power management that depends on the scenario. So in order to make this approach possible, we have identified different possibilities. The use of energy harvesting and wireless power transfer to have the possibility of not being connected to the grid all the time. For that, we also need accurate models for the energy consumption and balancing in the power grid to be able to compensate for the outages. Also, we need to be able to be infrastructure-less, and so also to be able to deploy flying base stations, for example, by using portable and UAV-based networks, and we need to be able to characterize all this together. So in order so painless actually, so the development of energy neutral and infrastructure-less wireless networks encompasses basically all these multidisciplinary aspects, thanks to the collaborations of a large number of partners. And we hope that this will allow us to really connect the unconnected through this paradigm. We have been working on that for the last few years. This painless is based on the research work of 15 PhD students, which were recruited through a very competitive process. You can find them here, and they are actually the people who are conducting most of the research within this project under the supervision of experienced researchers and professors across Europe. And I would be delighted to further discuss the research results and the research visions that we are developing within the painless projects. Meanwhile, if you want to know more about this project, we have a website from which you will be able to find all the information that you need in terms of technical approach, results obtained so far, schools that we also organized in order to teach our students new techniques in order to realize these visions. So I'm looking forward to discuss all these issues with you. Thank you very much.
Hello everyone, I welcome you to the panel on global 6G connectivity for connection of the remote areas and lower income neighborhoods. This is a IEEE PIMRC 2021 conference. My name is Alex Gacani, and I'm a professor at the RWTH University in Germany. So I will start with very simple drivers of for this topic. So United Nations developed goals for 2030 to bring undeveloped in the no poverty situation, no hunger, in a good health, in quality education, clean water and sanitation, and etc. 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 So when we think about the topic that we are now having on our discussion, I would like us to think about these goals, because actually these are the drivers for us to bring the technology there. So it is not only to make the coverage of those areas, but actually by bringing the wireless technologies to help improving some of these 17 goals, or all of them, hopefully. So this is, I would say, the introduction from my side on why I think that we do require these wireless technologies to be implemented. So how are technologies? So what we can do, how, which types of technologies, etc. So I will start with a very, very simple point here. So economy is a breaking point. It is actually something that will tell us if this technology will work or not, or if it's going to be deployed or not. So we have been seeing countries deploying 3G, 4G, 5G in different areas. Some countries in slower pace, some countries in faster pace, and that is mostly driven by economic benefits. So in the case of extremely low income neighborhoods, we are facing with a situation where we have people living on $1.25 per day. If you think about if I ask you what is your mobile subscription, or what is your internet subscription at your home, fixed access, this is way beyond this price. So now if you multiply this with 30 days, or not 30, with 20 days of a work month, we are coming to the position that these people earn less money than what we are paying for a monthly subscription of our internet connection. So this is what we have to think about. So we have to make our technology virtually free. We have to make this technology accessible in the economic perspective. So we need to make sure that our technology is cheap in that context. Now, the second point here. When do we deploy this technology? So this is related actually to the first point that I was elaborating. So we will start deploying the wireless technologies in the rural areas, not in the rural, but actually in the low-income areas, the moment that we have generated sustainable new businesses. So when we see that wireless technology has been generating the new incomes, then the new technologies will come and the area will start booming in different applications. So the most important aspect when we think about deploying the technology, deploying the wireless networks in the low-income areas, is that while providing the wireless networks, those networks should generate sustainable new businesses. Let's just think about an example. So this could be a very simple case where the network operators would think about certain business models for those people. Well, if we are talking about really low income or areas where still the farming is one of the major businesses, then online shopping, online sales could be one of the opportunities for those people to provide their harvest to the larger areas, which are actually hardly accessible with the transportation. So this is one of the examples. Yeah? So we need to generate sustainable new businesses. Those businesses will again trigger the new values, and the new technologies will start the deployments. Now the last point is what kind of technology makes sense? What would be this ultra low cost backhauling? What are the access technologies, and how to connect those currently unconnected areas with extremely low income? So we need to create, and we have to believe in the open and secure networks. Open network, I mean by not open access, but I mean open networks for the development of applications. So we are facing and we are witnessing the Open RAN initiatives, or several open initiatives for development of radio APIs that allow seamless integration of multiple vendors within the operator deployment. So this is a path forward, in my humble opinion, toward the provisioning of the low-cost technologies. So we are providing the APIs where even third-party application developers can work on to develop a new types of application that will be suitable for areas where we have such a low income, or even to provide opportunities for those youngsters to get a high-level education on the for the development of high-tech applications. So this is what actually my opinion is around this about this topic, and what we are currently doing. We can illustrate on this slide. So 4 universities, RWTH Aachen, the University Duisburg-Essen, Rural University Bochum, and TU Dortmund, together with several partners from Fraunhofer and Max Planck Institute, formed a consortium that is called 6Jam, that is funded by the German Ministry of Research and Innovations. And we are targeting to develop open, resilient, secure, and safe communication systems. So this is one step forward toward our goal to provide new technologies at really low cost to boost the economy, of the developing and developed countries, in order to bring wireless communications in the and the ICT area itself in the spotlight of the new innovations, new development, etc. So I will stop here, and I will leave to my colleagues for further, and then we can discuss afterwards. Thank you very much.
Hello, my name is Sudhir Dixit. I'm affiliated with the Basic Internet Foundation, of which I'm a co-founder, and also with IEEE Future Network Initiative. I'm also a docent at University of Oulu, and fairly active in the Wireless World Research Forum. So thank you for inviting me to the panel. I'll take the next 5 to 7 minutes to present my views. So with that, I'll stop sharing my video, and I would start sharing my presentation, which I hope you'll be able to see. Okay, so here is my presentation. I hope you all can see it right now. Okay, so the topic of my presentation in the panel is challenges for rural and remote connectivity for beyond 5G networks. Even though you may have heard this before, but to summarize, what does digital divide really means? The digital divide threatens our society if half of the world still remains underconnected or unconnected, close to 3.5 billion people. And because of that, there is huge cost for the society because they do not have sufficient digital skills. They are not contributing to the labor market. And they are also hampering innovation as well, because they don't have much purchasing power. And these people could also be contributing to the innovation in our society. And they are not able to adopt innovations that are coming out from the from folks who are innovating currently in every sphere of life. According to United Nations, Internet had the ability to dismantle the divide. But it has failed miserably. The divide is bigger than ever, and it's getting bigger as we roll out newer versions of the mobile standards. If you would prefer, you would like to read the book by Joseph Stiglitz, who is the winner of the Nobel Prize in Economics. The title of his book is The Price of Inequality, because they are hindered because of the lack of information about health, about education, about decent work, equality, and so on and so forth. The fact of the matter is that 50% of the connections in the world is still 2G. And this picture shows what the situation is in Middle East, Africa, Asia Pacific, Latin America, and the rest of the world. And we should not lose track of it as we work on 5G and beyond 5G and 6G. Some of the challenges for providing connectivity to people who are not yet connected is because a lot of these people are living in sparsely populated settlements. The population density is low. They have comparatively low income levels. They're living in regions which are difficult to access, requiring more expensive backhaul technologies. These folks also lack education and exposure to absorb digital technologies. There are local cultural and political nuances that inhibit empowerment of these people to take control of their lives. Also, there is inadequate grid power supply as well, and the price-benefit comparison is such that the mobile operators are not incentivized to offer services in the rural areas when compared to urban, suburban areas. We all know that the United Nations has set sustainability development goals in 17 areas. And to meet these goals, internet solutions are critical to attaining those goals. United Nations established a high-level panel on digital cooperation about 3 years ago, and they released a report in June 2019, and there were two main recommendations. One of them was that we recommend that by 2030, every adult should have affordable access to digital networks as well as digitally enabled financial and health services as a means to make a substantial contribution to achieving the SDGs. The other recommendation was that we recommend that a broad multi-stakeholder alliance involved with the UN create a platform for sharing digital public goods. Digital public goods are referred to the content that is relevant for the local population in the area of education, healthcare, agriculture, the verticals that are relevant for the local population in local languages. The hype versus reality about 5G is that the 5G technology and the previous versions have all been driven by technical requirements of the bandwidth, the latency, the mobility, and how many devices per square kilometers, and so on and so forth. But the needs of the developing world and digital disadvantages have always been overlooked. However, connectivity for all should have been one of the requirements when the 5G standards were being developed. So as we go to develop standards for beyond 5G and leading to 6G, societal sustainability should be one of the goals, and that should actually be the killer app for 6G if we do when we embark on 6G standardization. So there is no magic solution for connecting the unconnected or underconnected. The solutions are already there. And one of the solutions that the Basic Internet Foundation has been talking about is this lightweight protocol, such as accelerated mobile pages standard developed by Google, whereby simultaneous requests for a web page can come and they're delivered much faster by using the AMP protocol. The Basic Internet Foundation has developed a solution called for free access to digital public goods. We have a solution that relies on Internet Lite. Internet Lite refers to non-video content, which consumes only 3 to 5% of the network resources that can be delivered free of cost. And these digital public goods can reside both in the local server, in the local community, and all the content, even the video content, can be delivered for free, and the light digital public goods and the light content from the internet, which is the non-video content, can be delivered for free as well. But any content that is delivered which may be video content as well, that which is actually the video content is on a paid basis. We have demonstrated the solution coming out of the Basic Internet Foundation, which we call Internet Lite, in many rural areas of Tanzania, in 5 villages as are shown here, where antenna is about 6 meters high, and it can reach to the towers up to about 20 kilometers away. So this technology has been proven. So let us commit to an integrated approach for digital inclusion through national knowledge portals as well, because national knowledge portal is an architecture which is partly residing in the local community and also at the district level wherever the backhaul terminates, and also at the national level wherever the capital may be, or the state capital or the provincial capital may be. So content can be delivered from all these different locations of the portals depending upon where it is available, and the digital public good content can be delivered free of cost, and especially if it is video, it can be delivered free even from the local server. We are not forgetting that the connecting the unconnected can also take advantage of the network slicing concept, whereby the free internet can be provided over a network slice also to everybody, which we may call non-video content. We have demonstrated the Internet Lite network slice at the Oslo Metropolitan University in Oslo, and we have published a couple of papers in this area as well. IEEE Future Network Initiative has established a CTU working group that was established about 2 years ago, and they have published a white paper on CTU with 5G and beyond 5G about a year ago. There are a number of working groups in the Future Network Initiative, and one of the working groups is the CTU working group, as I mentioned before, which has a 10-year vision. And with that, I'll stop here and go back to stop sharing my slide here. And this is my final video here. I thank you for listening to me. And if you have any questions or comments, feel free to send me an email, or if there's a live part of the panel, you can certainly ask me any questions you may have. Thank you very much. Thank you.
Okay, thank you very much. So I guess we are going to move now to the live part of the panel, right?
Yes.
Okay, thank you for it. I would like first to thank Abhay, Albert, Marco, Haris, and Sudhir for their excellent remarks. You know, we have here really expert in this area and that have contributed extensively on this topic over the last few years. One thing I would like to highlight, and I assume that my colleague on the panel agree, having witnessed, you know, like let's say the deployment, the kind of, let's say the brainstorming that went behind 4G, and then eventually the deployment 4G. Same thing, the kind of brainstorming that went before 5G, and now we are seeing deployment 5G. I have not seen before this kind of enthusiasm or this kind of strong interest about connected and connected, at least from our community. There was probably a lot of discussion at the ITU and in some countries, but I have not seen honestly the same level of engagement from our research community on this particular theme, which is a good sign that hopefully this decade will be the decade where we will, you know, I will not say solve completely the problem, but start addressing it in a way that we will not have 10 years down the road still half of world population without access to broadband internet. So that's kind of a general remark that I want to make, at least from my perspective, and we'll see if our colleagues agree. So one of the nice things about this panel, and when we kind of put together this panel, is we have contributors coming from different parts of the world. We have from Marco from Europe, Abhay from India, Alberto based in South Africa, Sudhir, I think he's based now in the Bay Area in the US. So I would like each one of you, dear colleagues, to first of all tell us if you agree or disagree that essentially that you are seeing more interest, more engagement from the research community about this problem of connecting the unconnected. That's question number one. And question number two, from your perspective, from your part of the world. So all of us, including myself, kind of gave some high-level reasons, social, economical, technical. But I would like to say, from your part of the world, what is the main showstopper? Because maybe it's not the same for everywhere. All of these, of course, are combined together. But if you had to highlight one particular problem that really need to be solved in order to kind of address this issue, it will be nice if you can share it with our audience. So we can share, we can start, let's say, the way we start the video, and at least for this round of question, we can start with Abhay. By the way, I'm not seeing questions from the audience in the chat. So if you have questions, feel free to submit your question through the chat room, and I'll be happy to convey that to the panelists. So let's start with my two opening questions, and we can start with Abhay if you don't mind.
Thank you. Thank you very much. I think all the issues and the topics have been covered in a very comprehensive fashion by all my fellow panelists. Coming from the Indian point of view, and to give answers to your question, in order to have, a sustainable solution for connecting the unconnected, as I pointed out in my talk as well, there are two issues that needs to be addressed. One is the problem of the backhaul. It may not be possible to take fiber to sort of each and every part and to the remote areas. So therefore, we need to examine the possibility of wireless backhauls and how that can be used, particularly considering that in this beyond 5G and 6G, we are likely to have a significant throughput at the radio level. So the backhaul is one. The other aspect, as I mentioned, is that we need solutions for energy efficient operations of the base stations and the network nodes. So far, the research in signal processing and communications has mostly focused on energy efficient operations of the cell phones, because you want to have the cell phones lighter and you want the battery to last longer. And there have been like significant research in making the cell phones compact, lighter, energy efficient. But actually in connecting the unconnected, and particularly in low-income areas, I believe that the energy efficient operations of the base station is very, very important, because we may not have 24/7 electricity supply from the grid. And when we have to use the alternate sources of energy, renewable energy, then in order for these solar or any other renewable energy to become economically viable and also feasible in terms of, let us say in the case of solar, the area required, etc., we really need a highly energy efficient network nodes, which includes the base stations, the routers, the devices, the switches, and so on. So these are the two problems that I view needs to be addressed, both from the point of view of research in communications and networking, and also from the point of view of deployment.
Abhay, also just to make sure that you also maybe address this question, do you agree with me that it seems that there is a little bit more enthusiasm or a little bit more interest on this topic of connect the unconnected when we compare where we were like 10 or 20 years ago, when it was the start of 4G, they were kind of brainstorming, and same for 5G.
Absolutely. And I think the reason is that, the digital connectivity today is, affecting all, it's not just a means of, voice communications like human to human communications, but it is actually affecting almost, the way in which we live. So obviously it is important that, and all the people get connected in order to bridge this digital divide. And I think there is a renewed interest now in terms of both research and technology development.
Okay, thank you very much, Abhay. Very much appreciated.
Thank
Albert,
you.
can you tell us your perspective on this, please?
Thank you very much. I think all of the above more or less applies in Africa as well. I would guess the major showstopper is low income that population has, and so it creates a feedback loop. Low income, that means you cannot earn money quickly. That means you cannot pay for more advanced infrastructure. Also, if you think of Africa, say sub-Saharan Africa has about 63% in rural areas. And this can be compared to US or Europe having only around 15% in rural areas, which is 4 times the quantity. And rural areas are well known for much higher costs of deploying the infrastructure and running the infrastructure. I recall discussions around having to bring diesel to feed the base stations. There was a big project in one of African countries. I won't name it. They ran that infrastructure, I think, for about 2 or 3 years, as long as the government wanted to fund it. As soon as government stopped funding it, the whole infrastructure stopped working because it was simply unsustainable. Too few people, too high cost to deliver the fuel. There is statistics which shows, if I try to quantify, that the costs of deploying and running things in rural areas are 2 to 3 times more compared to urban areas. And therefore, there is lack of infrastructure. So access to ICT services is a challenge. Another big challenge is languages. I'm sure people in countries speaking French would partially agree with me, as an example, or Spanish, because the main medium on internet is surely English. I think countries like China and Russia, they managed to at least partially get around this problem by quickly creating local platforms equivalent to what is offered, what has been traditionally offered from the US. For example, there is Facebook in US, and there are 2 similar platforms in Russia. There is Google that offers maps and other services. And there are similar platforms that exist in Russia in Russian language. Obviously, most of the people are going to be using platforms which they can use right away. So language, I think, is a huge barrier. If you think of the statistics, which was shown in a couple of slides by now, there are 3 billion people not connected to internet. The important note about it is that they are not, maybe not connected, but most they actually within coverage. So they are choosing sort of not to use internet. So the questions would be about whether internet is relevant to them or not, and whether they can afford the terminals. So I think those questions of relevance are very, very critical for creating new business models which would be good for African countries. I can maybe give a quick example. So Uber, in my view, created jobs in Africa because maybe it is global platform, it generates profits in US, but it creates jobs locally. Delivery applications. So online shopping is shopping. I think most of the large shopping chains in South Africa, they do delivery. So you order things online and they deliver, and that again, it created local jobs. Right. We have friends in Norway, and we tried to find online delivery in Norway, and I found, okay, it is scarce there, to my surprise. Right, where they deliver is very limited, and which shops deliver is also. I think it's because in Norway the delivery costs are high, in South Africa delivery costs are very low. So things simply work. So I mentioned languages. Yeah, and the last thing I wanted to mention, access to spectrum. I think that
yeah, we will,
yeah.
Albert, the spectrum issue, we'll kind of dedicate some time to it later on, because that's definitely an important topic.
Right.
I think
it's exciting topic. So.
Yeah, I know that you have a lot to say about that. Unfortunately, my understanding, Marco had a last-minute flight, so he might not. He might be a little bit late, or he may join later. So let's move to Harris. Harris, do you want to comment on this kind of a question that I asked about maybe from a European perspective? What are the main? What is the main, let's say, stop shore for this? You know, by bringing global connectivity, in particular to rural areas and maybe a remote area within Europe?
Yes. Okay. So, how many minutes do I have for the expose?
No, like up to 5 minutes. That's fine. I mean, like,
okay. So the previous colleague was talking about African countries, and I think there's quite difference between accessing the rural areas in Europe and Africa. In principle, I would look at it from a communication point of view in this way. There was this strategy that we put the fibers, we put the fibers all the way somewhere, but it's really absolutely unacceptable economically, and I'm not sure if that way will ever work. Then there was an approach that we use microwave links in order to bridge over the certain areas in order to reach to the areas where we have urban, or let's say suburban communities. Then we had these exhibitions with the balloons, with airplanes, but I mean, I don't want to comment further on those. But what is, from my perspective as a researcher, quite intriguing is it is not a problem that we bring high data rate to the rural area. We can bring it to some fashion, but then comes one of the questions from the list is, then what? There are no business models for those investments to be paid out. So we are looking into the distribution of high data rate to the rural area, and then we can look into what do we do then. So then we are looking at a large number of very small and dense areas to be covered with access points or small cells that are of high capacity but small ranges, many of them, and this is something that is economically very difficult or challenging to be paid out. So what is the most important is that the business models that technology will initiate at those rural areas come into the play. So in Europe, situation is much better in the context that we already have digitalization of agriculture. So agricultural products are already available directly on the websites from those first-hand producers. So you can already order some of those products directly to your home. However, when this kind of services will be initiated in the, I would say, developing countries, that is another story. But from the communication point of view, I don't think that we have any problems. We can deliver, we can bring those high data rates, but the problem is that we really have to consider the business cases. And now with the producing the, generating the business case that will bring revenues, we come to another story of what we are talking about, remote access to schools, remote access to high level of education. So, for example, many of the universities already have this distance learning, but they are having distance learning for those who can afford the distance learning, who can pay for it. But we are talking about areas where we have to actually be heartful, and we have to actually help them to bring them to the level that they can be sustainable. So then the new use cases will come about augmented reality or virtual reality, bringing new schools, and bringing you and some remote area to my classroom, to my laboratory, where they can actually do experimentation with my equipment in the virtual world. So this is something that I would be driven, and I am driven with. And if anyone has any kind of ideas how we could bring this to the world, I would be more than happy to participate in these kind of projects. Thank you very much.
Thank you, Harsh. Very interesting point. So yeah, we have seen different remarks now, like backhaul, content, business model. So of course, all these are important. Sudhir, do you want to add to all this from a US perspective, let's say?
Thank you for asking me those questions. So to begin with, I would say definitely there is a lot of interest in connecting the unconnected all over the world, especially as we develop technologies beyond 5G. So that's the first comment. So all the presentations were excellent. There are 3 or 4 main drivers / impediments, if I may put it that way. Number 1 is obviously affordability. Affordability falls within two dimensions. So one of them is CapEx. The equipment cost needs to be very low. And the second one is OpEx. And those both have to come down. It's not about developing new technologies. It's about bringing costs down. So OpEx and CapEx, they need to come down. And the second thing is, so affordability is number 1. Number 2 is the community engagement. That is extremely important. Community involvement is important, and because that helps to bring down the OpEx. If they can play some role in operating the equipment, in housing the equipment, and providing power and capacity building among the people, so that plays a big role. Community engagement and government support. Without that, nothing can be done.
Subsidies, yeah.
And then there are local cultural issues too, because in villages there is a power structure. You know, the village head has the power through whom people get their benefits. And if you empower people, whereby the village heads is bypassed, it creates disturbance in the ecosystem, in the power structure. So there are these cultural and local non-technical nuances that have to be dealt with. And we need to somehow create this micro operator ecosystem so that we don't have to rely on big operators to serve these unserved areas. And from the US point of view, as you mentioned, actually this connectivity is not an issue just for the developing world or the people who don't have the capacity to absorb technology, but it's a universal problem everywhere. And that has become, that has surfaced with because of the COVID situation. People have to rely on internet to do their business, to conduct their day-to-day lives, as was mentioned by Abhay early on. It's not about communicating, it's about doing things on a day-to-day basis. So people are relying more on internet, and that has waken up everybody, both in the developing world and the developed world, to do something about it. So it's an issue in the US, a big way. The rural areas, they're having problems of connectivity, of not having to provide enough capacity to school children. How do they get remote education? And that has become a challenge for the parents, how to keep children engaged. So it's a universal problem, and internet is the only way to do it, because you can't build the physical infrastructure fast enough, and it's very expensive. But building internet is a lot cheaper. So that's the way to go. So I'll just stop here.
Okay, thanks a lot, Sudhir. So, let me combine, since I still don't have questions from the audience, let me combine two of the questions that we have in our panel list of questions to be addressed during this discussion. And I will start a little bit in a reverse order. We'll start with Sudhir this time. So I'll give you some time to think, Sudhir. So this question is, now that we talked about the challenges, and pretty much I think you all agree on what are the main challenges, maybe with different level of priority depending on the region in the world. Now that we are all engaged in trying to solve this problem in the coming 10 years, and given that we said that the business model, I mean, like this kind of affordability seems to be kind of a big problem. Do you have any idea what will be really the best business solution, or have you seen some kind of very clever way to kind of come up with a sustainable, let's say, business model to connect the unconnected? And I'm combining this with the third question so that we kind of progress a little bit faster. We all know that part of the expenses is actually sometimes the license that the MNO have to pay for the spectrum. And do you think that using the unlicensed spectrum, and here I'm basically highlighting some of the research being done by Albert on TV white space. I know in the US also this new experiment with CBRS. So I'd like to hear from you about these two aspects. Basically, innovative business models, one point, and then the spectrum issue and unlicensed spectrum as a way to lower the cost. Do you think that's a good way to go? Sudhir, if you don't mind, we can start with you for this question.
Okay, so on the business model, as I mentioned, we need to encourage this micro operator ecosystem. With micro operator, I don't mean somebody from urban area coming and developing the infrastructure. Somebody from the village, the rural area, remote area, they need to step up and build the local infrastructure and provide the connectivity. Because the people who are a local entrepreneur probably is not looking for a huge return on investment as a big operator or an urban player. So if a person who is local, he or she would have a local buy-in also. And this person can promote and can get the acceptance to sign up with the internet much faster than somebody coming from the outside who would be perceived with some suspicion to begin with anyway. So this micro operator ecosystem developing from the local perspective, and that's where there is some policy, some policies need to be amended at the government level, whereby the rules and regulations are loosened for these micro operators. And to bring down the cost low, we need to think about how can the equipment be housed in some people's houses. They provide the power, and in return they are provided free service, and so they have the incentive. But it's not that they are given free service. They just provide the equipment, but there is no monitoring. So, but they should also be monitored as to what has been the uptime, 24/7, how much time the network has been up, have they been maintaining it, and so on and so forth. So that can bring down the capex and opex both low if we have the community engagement. And this individual or a set of these users would have more trust among the rural community to become users of the internet. So that's on the business model side. On the spectrum side, again, we need to have some loosening of the spectrum policy so that the spectrum is given out free of cost, or it is given out at a very low cost to rural communities, because there is no issue of interference there. That's number one. But also at the same time, the urban big operators should be closely monitored so that they do not come up with some loopholes to use this free spectrum for their ulterior motives, because that always happens. So there should be strict penalties of abusing these loosened policy of the spectrum for rural areas. And I completely agree that TV white space has a huge opportunity to provide backhaul. That must be leveraged. There's absolutely no doubt about it. And that's where the government has to play a big role. So I know I was in one of the CTU meeting just an hour and a half ago. And I know I'm digressing a little bit here. And some people said, well, we should start talking about human rights, that internet should become a human right. And I said, please don't do this, as soon as you start talking human right, it becomes a political statement about democracy, about the Western world, and about this world. That don't use that, So stay away from these political things. Talk about the empowerment of people, empowerment of the local community, providing access to free information that is so available, and we achieve the same thing with other means. So to answer the second question, it's a global problem of providing enough capacity everywhere in the developed world and the developing world. It's not a problem only for certain regions of the world.
Okay, thanks a lot, Sudhir. Haris, do you want to give your input on this particular point?
Yes, actually, let me start by commenting to that's what I just heard. I have to say, to some extent, I really don't agree, but it's not that I think that Sudhir is wrong. No, I think because regarding the business model, I think we are looking at in a wrong fashion. So we have to look in the context of who do we want to deliver connectivity. We are delivering the connectivity to the people whose businesses are agriculture, farming. So we are talking about remote rural areas. We are talking about the people who maybe have not been educated. And now I really have this inside of me, this wish that we can be a world of humans, to say we have to give from ourselves to bring others to the level that they can be sustainable. But the question is, what does it mean sustainable for those people? So we bring the connectivity to them. What will they do with it? Their life is very simple. They go up when the sun comes. They go down when they go to bed when the sun comes down. So I think bringing the sustainability to those areas, to those people, means that we have to educate them. We have to find a way that connectivity comes for free for them. No matter, I mean, okay, now people can laugh, but I really believe in that. I believe that we have to, as a community, find a way to sit together, form a small group of people who is going to look for some opportunities to bring education to those people through the connectivity, to bring them remote schooling. And by doing that, you will be able to bring the generations, but this is not tomorrow. This is not 10 years. I'm talking about 50 years of process to bring those people to the level that they can program, that they can do remote programming, solve some codes for somebody and get some money directly on their account. And from there, they can then start investing in their own communities locally. And this is from where then higher rates, higher data rates, higher, more sophisticated technology will come as well. But I really believe that we are looking at it from our technological perspective. Yeah, okay, we just have to come there and bring them the network. But those people don't, at this moment, they don't need connectivity. They are connected in their own world with their own way of communication. So so this is what I really think. I think that discussion also needs to go to the beyond our technology. It needs to go to our human side to say, okay, what we can we do anything about it? I know that the German government had a lot of programs where actually they were fostering such sustainable development activities in the African countries. So I have to admit, I have never participated in any of those, but such things are necessary. So we don't need maybe high data rates. We don't need 6G to them. We need connectivity to bring them some basic knowledge that they can grow. Regarding the second point on the spectrum, yes, I don't think that actually it matters for those, because they cannot pay for it anyways. So again, we are coming to a situation where there was this regarding the business model that Sudhir was mentioning, that those locals have to bring some micro operators, they have to build themselves. Yeah, but yeah, the real question is, can they do it? So the spectrum as a spectrum in such a case needs to needs to be regulated in a different fashion. It needs to be regulated maybe on the basis of needs rather than the buying power.
I think here you are in agreement, Sudhir, and my understanding, Haris, if I'm not wrong, is that in Germany actually there are such kind of policies. It seems that Germany is among these few countries where licenses are not given on a country based, but it can be given on a regional or area based. So it seems that Germany is in advance compared to other countries regarding spectrum regulations. And I think, I don't want to speak on behalf of Sudhir, but what he means by a local entrepreneur, I think he's talking here more not maybe from a like a European or like a, let's say, a German perspective, where maybe the government has enough money to go and from a public service perspective install capital equipment in remote areas. But sometimes when you go to some of these developing countries, the government is already struggling with other priorities. So to make I guess, and again, Sudhir, correct me if I'm wrong, I think what you are saying, to make it kind of sustainable from a business perspective, you want to see someone from the community taking the lead, hosting the equipment, maintaining it, earning a little bit of money in terms of free service or some other ways of kind of getting into an advantage or benefit, so that basically there's an incentive to run the operation. I think we are talking about that kind of setup, not US or maybe or Germany, but so different country may have different kind of needs and different kind of solutions.
So that will provide business sustainability from a local perspective, and also scalability.
But of course, if the government is strong.
On the topic of a spectrum, there is already some discussion going on that the spectrum should be given out for free, because
like the whole spectrum?
Because it is a natural resource like water, air. Radio waves are free. Government should not be making money, but of course they need to regulate it for interference reasons and other things. And it should be coming out from, and the cost of regulating should come out from the taxes that we all pay anyway. But it should not be, government should not be making money, profit out of it. And that will bring down the cost and affordability for everybody. Anyway, I'll stop here.
I mean, I think this is going to be bad news for many government and countries who are relying a lot on spectrum auction to make some money out of it. But anyway, so Albert, do you want to add to this? And Abhay after that, but let's start with
let me just to say this. Just to say this, so when you said the problem is, I mean, even if you do, I mean, the government cannot make the money out of it anyways, because nobody will come to buy it because there's no business value in it. I mean, you just don't want to pay.
Service. It's more of a public service. Exactly. But that's what I'm trying to say. A country like maybe some European countries where they have the budget for that,
that is
they
different.
can afford to have the public service. Some other countries are maybe struggling with other priorities. Like even bringing water or sometimes electricity to some of these remote areas. So there are often sometimes priorities in the budget.
I mean, and then I will not say further until you call me back. Many people from Europe go and make wells, water wells in Africa. They go collect money. They go together. They make fantastic things. They improve the lives of the people with such a thing is amazing. And I think with respect to the connectivity, unfortunately, but it needs to be in a similar way. Whatever that means. Yeah. But okay. Maybe I'm too Robin Hood kind of. Okay. Yeah.
Albert. Okay. You have also your kind of niche type of topic, spectrum. So you can tell us a little bit about your experience with TV white space in South Africa in particular.
Okay, I thought TV white space has started commercial. I mean, we developed our own geolocation spectrum database, and it's been adopted for national use, and operators are starting to use it. But I think it's a little bit too early to talk about TV space in terms of the business models in Africa. We need to gain a little bit more experience. But there are a few I think important points which the previous speakers highlighted. I agree with Sat here about if you want to make impact now, then it's not about new technology, it's about bringing the cost down, and the 4G is probably the best way to go around it. It's very popular, it's good enough for most of applications. Now, I agree with Haris about the need for education and lowering costs. Well, in South Africa, I think we are considering having a zero-rated basic access to internet. Right, during the pandemic, zero-rated access was introduced for providing education. So a specific set of websites was rated as zero-rated access for students and pupils to be able to get education. And I think, yes, it might be not a bad idea to extend this idea to entire population to provide a basic package, even if it's 100 megabytes of data per month. It would, well, if I speak the drug dealer type of language, hook people on internet and create the need in those 3 billion people. I spoke about 3 billion people not using internet. In comparison, 750 million people are really not connected. That is, they are far away from connectivity. 3 billion just choose not to use it. To highlight the point Haris made about the languages, in Tanzania, 98% of population speak Swahili. Right, and when Facebook was introduced in Swahili, the number of users increased drastically. Basically, if you look at the plot, it is a flat line and then drastic jump. So people started to use it because language was available. Another alternative I would like to propose, which wasn't mentioned, I think, is if you want to go for the technology, and especially for something as popular and cheap in terms of terminals of 4G, we probably need to look at trying to simplify the 4G base stations and lower their costs, so that anybody can just take the base station, install it, and use it, well, preferably with pressing one button. Maybe Apple can do that. They usually do things magically with one button. button. Well, practically speaking, I understand that we need to manage users and so on, but it's a possibility. If I take the idea of village operators that here spoke about, why don't we maybe take it even step further and make it nano-operators? I'm taking into account that typically a scale of production influences the cost. So if we can affect this, the costs in urban areas, we can help the costs in rural areas as well. And if we can propose, okay, in 5G, in especially 6G, we want to have high capacity, which requires a lot of base stations. And few companies would have enough money to bring it up quickly. But what if we offer individuals living in houses and flats to become operators? So if they buy a base station, say they buy access point, but if the access point has firmware allowing it to also act as a base station, and if the person can sign up for it simply enough online to become an operator, then it solves two problems at the same time. Right. Okay. I think let me maybe stop here because there is a separate point about spectrum which you want to discuss later.
Yes, very good. So let's hear from Abhay to kind of wrap up on this question, move to the next question, which is in a way aligned to what we have in our agenda, but also is coming from Christoph in the chat. So let's have first Harris. I will give you the mic one last time after Abhay. Go ahead, Abhay.
No, I think I just want to elaborate on the point which Sudhir said about the village level entrepreneurs. In fact, this concept has been tried extensively in India. And actually, the basic idea is that, the large operators often have a lot of cost overheads just in terms of acquisition of the customer, because they have to acquire the customer, they have to make entries in their database, and then they have to serve. This itself actually makes the business operations unviable. Forget about the cost of the networks and the cost of the spectrum. Just for a large operator, just the cost of acquiring a subscriber and then billing him itself is a big part of the operational cost. So in that sense, having the concept of rural internet service provider or the village level entrepreneurs, which are actually buying the bulk bandwidth from the large operator and then servicing it in the rural areas where they can manage the local subscribers, does reduce the cost of the operations in a very significant way. And I think the point that was made that we need to empower the local villagers first of all, we need to create contents which are relevant for them. We need to create contents which are in their own languages and which are useful for them. So I think those use cases and the education for the villagers are extremely important. And in this context, I feel that the rural internet service providers and village level entrepreneurs can actually play a significant role. I mean, of course, Sudhir mentioned that one of the local person has to be there, but it is not necessary. It is not a question of who becomes, the rural internet service provider. The point is it has to be an operator which needs to serve the rural areas, which needs to buy the bulk bandwidth from the large operators. I think that part is what Sudhir was mentioning is, I think, extremely important because that does reduce the operations cost. Regarding the spectrum, I think it is important that we, in order to serve the rural areas where there is a large geographical coverage, we need spectrum which has good propagation characteristics. So therefore, deploying these networks in the sub 1 gigahertz, which are like 700 megahertz spectrum and 500 megahertz spectrum, are extremely important. The irony is that in most parts of the world, when the spectrum is auctioned, this spectrum, which is called as a beachfront spectrum, is actually the most expensive spectrum. Okay, so this turns out to be the most expensive spectrum. However, what we believe and what we have been arguing in India, at least, that this spectrum, I mean, it is always possible for the government to auction this spectrum at the market prices in metropolitan region and in the tier 1 towns, but can always make this spectrum available at either in a lightly licensed fashion or at a lower cost in the remote rural areas. So I think spectrum can be auctioned based on the regions wise. It has been done in the countries, even in India, but the cost needs to be substantially reduced in the rural areas, maybe making it, if not unlicensed, making it lightly licensed and evolving, some policy of sharing the spectrum. So I think these issues are extremely important in order for the deployment and the operations cost viable for the connectivity to be provided.
Great. Thanks a lot, Abhay. Great remarks. Let's give the mic for Haris for a few extra minutes to wrap up this particular topic and move to the last topic of our discussion. Haris, go ahead.
So there were 2 points. One, so there was a question. So do you foresee charitable activity bringing connectivity to under connected areas?
Yes.
My answer is yes. Yes, I think that is what we should aim for in some way. Second, there was a question here, as you have seen, about satellite communications.
No, this I will,
you will address the second one, yeah?
Yeah,
okay.
This is okay. Thank you for answering the question of Fouad regarding this analogy between sending charity for water and electrification and adding to it like the connectivity as a third aspect. Let us now move to the last.
Just to add, sorry, just to add to when this connectivity comes to these areas, I'm not talking about the Facebook. I don't talk about we bring people likes and sharing of the images through the Facebook connectivity platform, but we are bringing people life sustainable activities for their well-being. Yeah. Okay, that's it. Thank you.
Great, thanks a lot, Haris. So let me kind of ask the last question that we will use to kind of wrap up our panel. It's related to what Christoph asked. So the question is around basically what we think are the most promising, emerging, innovative solution for backhauling. So in order to essentially reach these remote and these rural areas. So Christoph actually is giving a good hint here for the audience, is about the evolution that we have seen in satellite technology that's becoming more and more affordable. And obviously, yes, there was an early generations of LEO satellite like Iridium and Globestar that went more into the IoT type of market. But now with the emergence of this mega constellation, and here we are talking about Starlink, Kuiper, and so on. Do you see that as a viable or as the most promising backhaul solution for connecting the unconnected in remote and rural areas? We can start, let's say, by going in reverse mode again by Abhay.
Okay, so
I know that OneWeb was kind of in particular, like in part saved by one of the big Indian kind of cell companies. So maybe there is this kind of a nice synergy here. So you may want to comment on that.
Yes, I think this appears to be like an attractive option. And I think there is a possibility of experimenting this in the rural areas. We need to see how much we can get the backhaul throughput and what kind of traffic can be backhauled. So this certainly is one of the possibilities. The other possibilities which we believe is V-band and E-band, particularly using 66 to 71 megahertz in a multi-hop way. And that possibility is also there, where the both the V band and the E band can be used for the backhaul. The other possibility is also actually, we think that, in the rural areas, population lives in clusters, actually. It's a sparsely populated and it lives in clusters. So in such areas, you could provide the access through the small cells, but then these small cells can be backhauled over a large area using sub-gigahertz spectrum. For example, the TV white space spectrum, which was talked about, could be used as the wireless middle mile. So it's not really exactly a backhaul.
Yeah, mid-haul kind of thing. Yeah,
it's a mid-haul, and then you get it connected to wherever the next fiber point of presence is there to backhaul eventually the traffic. So I think these are the possibilities, but satellite is definitely a possibility in areas where it is really difficult to approach.
Yeah, deep rural area, basically.
Yes. So I think a combination of satellite, sub-gigahertz, and V-band or E-band can be used depending upon the topography of the regions, and and what are the throughput requirements, how is the population is clustered. So I think those are what the possibilities I feel.
Yeah, fully agree. Great. Yeah. Like Harris, do you want to comment on that, on backhauling?
Yeah, I really agree with the previous speaker, more or less. So we also have this satellites as potential as our for the backhauling, but what also can be a part of the discussion is the our drones. So now the question is how we will implement it, but that could be one of the opportunities as well for us to provide some connectivity to small but maybe densely populated areas. Definitely another option is to utilize some, as mentioned, midpoints where you will bring some high data rates, and then from there jumping on the so that is more or less I would agree with the previous speaker's comments. I would not like to repeat it. Sorry. Yeah.
Okay, very good.
Thank you.
Albert.
Thank you. Well, I would happily agree with the previous speakers in terms of the innovative technologies that are coming up to provide connectivity. And yes, you mentioned the research from some from US, some from South Africa, showing that TV by space indeed offers the lowest cost of connecting people in rural areas. Basically, you have frequency which is at least twice lower than anything else available for commercial spectrum, and therefore you can increase your distance twice, increase the area 4 times. So TV by space is a good opportunity in that regard for backhaul. For access, I would think the 4G. In terms of other innovative technologies using spectrum, CBRS, I believe, has shown quite a success in the US. The power spectrum auction shows that 3.5 gigahertz spectrum attracted the highest, I think, highest ever number of organizations who won the licenses. Over 2,000 organizations in the FCC auction. And they already have over 100 installations and over 200 CBRS capable end user devices. So yeah, it's as a technology, that's a good way to go. In terms of the cost of spectrum, just 3 small points. One is that spectrum, if you look at the statistics, you will see that the average cost of spectrum around the world has been going down until 2008. And then 4G started to pop up, and the cost of spectrum started to steadily go up since 2008 about. And it reached a ridiculous value of, I think, $81 billion in January 2000 this year in US. for just 280 megahertz of spectrum. But here my question is, do we really need spectrum? If the technologies continue on the path of 4G and 5G, that is backward compatibility is assured that the 5G can reuse spectrum for 4G, and if 6G can reuse spectrum from 5G, and policies don't put any stumbling blocks on it, then the cost of spectrum is going to be a problem no more, because you can just go, okay, in dense urban areas, you would want your capacities, you need new spectrum. You always need new spectrum. But in rural, remote areas, as speakers highlighted before, spectrum maybe is less of a problem then. But since this topic is focusing on the promising technologies to connect urban areas, I wanted to highlight one important point which didn't seem to fit well anywhere else. Okay, we need to use the internet in order to grow its user base. But I think global operators need to be careful about trying to keep the balance between globally provided services and locally provided services. If OTT services are provided from a few global players, that means the local infrastructure would have difficult time to grow. And that means those very languages are not going to be well supported. So we are going to be back at square one. So there should be a balance in the business models in providing the just access to internet as a raw pipe and supporting local development of applications for the service, because this is the way we create a sustainable business. Thank you.
Very good. Thank you very much, Albert. Sudhir, you'll have the last words. Sudhir, are you with us? Okay, maybe Sudhir has some connectivity problems. So what I would like to say, as I mentioned earlier, there is a big interest in this topic. In the fall, there are multiple events focusing on this theme of digital divide and connecting the unconnected. In particular, I'm organizing towards the end of this month, September 28, 29, and 30, what we are calling a 6G Summit on Connected and Unconnected. It's a second edition of this summit. This year is under the kind of umbrella of the Marconi Society. It's 3 panels, the same kind of the panel we have seen today, with a big involvement from industries like OneWeb, like Facebook, like Google. So you are all invited to register and to attend for free this event that is going to be organized online towards the end of this month. I know also Sudhir, if he's still connected, has been quite involved within IEEE, and there is a big initiative run by the Communication Society, and there is a big event also to be organized, I think sometime in October or November. So I think if he reconnect, maybe he can tell us a little bit more about it. But in any case, I'm sure if you Google it, you will find it. There is, or if any one of you in the audience is aware of this event, can tell us a little bit more about. But from what I remember reading, it's also like a kind of a summit or a workshop that is going to be focusing on this theme. So you'll be, if you're into this topic, you'll have an opportunity to hear from different other perspective and maybe hear about some real deployment on these technologies. With that, I think we are coming towards the end. What I would like to do now is maybe give the floor for each one to give some concluding remarks and just wrap up the panel. We can start with Abhay. Abhay, if you want any concluding remarks or concluding words.
No, I just want to conclude by saying that it was like a great discussion. A lot of interesting opportunities. And as you mentioned in the beginning, that there is now a renewed interest. And if all the research communities put together their thoughts, I think it should be possible to bridge the digital divide and get the unconnected connected with the future technologies and the solutions and also the innovative business model that we discussed today. Thank you.
Good. Thank you, Abhay, for all your valuable comments. Albert, any concluding words?
Yeah, I think I would just like to thank you and the conference for the organization of this panel, for keeping this important topic highlighted and promoted, and for discussing well, a variety of important innovative ideas to help to move research forward in the right direction, to sort of give the research not just a purely technological direction, but direction which comes from the needs of the people. Thank you very much.
Great, thanks a lot, Albert. Haris, please go ahead.
Well, I really want to thank you for organizing this. At least that was really a challenge. I think I have missed the first hour. Reason is that I did not understand that local time means local Finnish time, not local CT or local Belgium time or Germany. So I'm really, my deepest apologies for that. But at least the hour that I was there, I really enjoyed in the discussions. So I think, yeah, definitely I'm looking forward for the future in the following 24 years of my active service in the work, that we bring this to higher levels and to bring the lives of the people to something much more, I would say, better. Thank you very much.
Thank you all. Sudhir, are you back? Sudhir? Oh, okay. So maybe he has some other commitment. So let me conclude. We are basically coming to the end of this 2021 panel. I mean, yeah, PMRC 2021 panel on connecting the unconnected. I would like to thank the 6G flagship initiative. This initiative that is basically, as you know, headed by University of Oulu. We have a representative here, Nurul Huda Mahmoud Fouad, who helped us basically arrange for this panel, and who's heavily involved in this 6G flagship initiative. Thanks to this initiative, we have a very active group of researchers who are interested by this theme, and who helped me to kind of prepare this panel, invite speakers, define questions, submit a proposal, get it approved. So in particular, I would like to thank Vimal, I would like to thank Khalid, and I would like to thank Hari from this 6G flagship group on Connect the Unconnected for making this happen. I see that Sudhir is back, so I will conclude. And I see Vimal here. Thank you, Vimal. Thank you, Khalid. Thank you, Hari, for your help putting together this panel. So I would like to give the floor to our colleague, Sudhir. Sudhir, I was saying that as part of our concluding remarks, that there is a kind of a really great interest in this topic. As you know, as you may know, I'm organizing kind of a summit towards the end of the month. I know that you are also heavily involved in organizing a ComSoc IEEE event sometime in October, November. So maybe it's your opportunity to kind of make some publicity for this event and try to make people register and attend online for the event that you're organizing as part of this ComSoc initiative. Go ahead, Sudhir. No, you are muted. You are muted.
Sorry. I think most of you may know that IEEE Future Network Initiative is organizing a global challenge for connecting the unconnected with about 14 awards in many different categories. And we received close to 270 contributions, out of which 114 or 112 went through the first round of approval process, and after that we received about 70 or 80 full proposals that are undergoing second phase review process right now. And they will be informed about whatever the decision is to about, I can't remember how many. They will be informed to have one-on-one presentation with the selection committee. So so that The CTU summit is happening in the beginning of November.
Okay.
And I know, Slim, you are part of it. Abhay, you are involved. And I know, Albert, you have been in the discussions. So many of you have been part of the CTU working group in the Future Network Initiative. So thank you all for being part of this global initiative. And the main reason why IEEE took a Future Network Initiative took the initiative is to bring all these hundreds of activities that are going on around the world to create some kind of a critical mass, make this challenge of connecting the unconnected more visible, and make sure as we develop standards beyond 5G, leading to 6G or 5G, that it becomes one of the requirements. So that we just don't focus on the technical objectives, but there should be social objectives as well. So that's the other purpose of having the CTU working group in the Future Network Initiative.
Very
So,
good.
Thank you.
Thank you very much, Sudhir. So I think with that, we kind of are coming to the end of this panel. I would like to thank all our distinguished panelists, Abhay, Haris, Albert, Sudhir. Of course, I would like to thank Marco, who gave some opening remarks, but who had some last minute kind of issues that didn't allow him to be part of the discussion. Thank also for the audience for your attention, and looking forward to meeting you maybe the semester still online for the few coming events, and hopefully in 2022, finally face-to-face. Thanks again and take care.
Thank you.
Thank you. Thank you. Bye.